Recently, Spring Boot team they released a new version 3.1.0, and inside this new version, Spring Boot team they introduced a new interesting module, and this new module is going to provide an out-of-box integration between your Spring Boot application and Docker Compose. Before I try to explain you about this new module, let me try to explain what is the problem that this new module is trying to solve. On day-to-day basis, Spring Boot developers, they develop a lot of REST services, microservices, or web applications. And all these Spring Boot applications, usually they need supporting components like database, message queues. So to run these applications inside their local, usually developers first they need to make sure that the supporting containers like MySQL database container or message queue container is running behind the scenes. Once the Docker container is up and running, then only the developer can start his own Spring Boot application. So if you can observe, there is clearly a manual work is involved where the developer has to make sure that a particular supporting container is running behind the scenes. Otherwise, the Spring Boot application will not start. So this is the exact problem that this new module is going to solve. This is a super interesting module, and I really like this new feature that got introduced in 3.1.0, and this also shows how much Spring Boot team is thinking about the developers' productivity. I know you may have a lot of questions here. First, let me show you all the pain process or cumbersome process that a developer usually go through whenever he's trying to work on Spring Boot applications that are dependent on the Docker containers. Here inside my IntelliJ IDEA, I have an Spring Boot Maven application with the name accounts. This is simple Maven application where I have REST APIs developed. If you can open this main package and go to the controller package, you can see I have a controller class with the name accounts controller. Inside this accounts controller, I have configured the base path, which is API/accounts. And post that, if you can observe, there are 4 methods supporting the CRUD operations. The very first one, which is create, which will help me to create a account inside a bank application. And similarly, there is a fetch API, which will help me to retrieve the bank account details from the database. And post that, we also have an method supporting the update operation. And towards the end, we have delete method as well. So this is a basic Spring Boot Maven application. If you want, you can explore about this application, what this application is doing. On a high level, I have taken a Maven application which has REST APIs exposed to perform the CRUD operations on a database that I have configured behind the scenes. So as of now, you can see the database right now I have under these resources application.yaml is H2 database. So as of now, my application is using internal H2 database. So this is the initial version of the Spring Boot application. First, let me try to start this Spring Boot application and I'll show the quick demo of the APIs that we have. So here, this is the main Spring Boot application class. So let me start in a debug mode. Once the application is started, we can test the 4 REST APIs that are supported by this Spring Boot application with the help of Postman. My application started successfully. Behind the scenes, I'm also creating a couple of tables with the help of schema.sql. If you can observe the Maven project that we have under this resource folder, I also have schema.sql. And inside this, I have mentioned the scripts that will create the tables, customer and accounts in the database that I have configured. So as of now, I'm using the H2 database. That's why you can see during the startup, these 2 tables are getting created by the Spring Boot framework. Now let me go to the browser and show you the H2 console. So I'm trying to access the localhost 8080 H2 console, and this is my H2 console, and I'm trying to click on this connect button. And as of now, you can see there are 2 tables created, accounts, which will not have any records. And similarly, we also have customer table, and this will not have any records. So now I'm going to invoke the REST APIs with the help of Postman, and post that we can validate if the data is being populated inside this H2 database. So here first I'm trying to create a new account. So to create a new account, we need to invoke this API, and to this API, we need to pass this JSON data inside the body. So the data that we need to pass is what is the name, what is the email, and what is the mobile number of the customer who is trying to apply for a new account. So as soon as I click send, you can see I'm getting a 201 status saying that account created successfully. Now I can also validate if my account is created successfully or not by invoking this fetch API. So to this fetch API, we can pass a query param mobile number and the registered mobile number value. So let me take the registered mobile number value. The same I'm going to mention here. And now I'm going to invoke this fetch API. And as soon as I click on the send button, you can see I'm getting a response that these are the customer details and these are the account details of the customer. So there is an account number created and the account type is savings and the bank branch address is these are the address details. So my account is created successfully. So let me try to test the update operation as well. So to the update operation, we can pass this body. And inside this body, I can mention all the fields, like what are the fields that I want to update, like name, email, mobile number. And inside the accounts DTO, I can mention the account number, account type, and branch address. Basically, whatever response I'm getting here, I can mention inside the request of this update operation, and I can change the details. You can see here, while registration, I have given the name as Madan Reddy. Whereas in the update operation, I'm giving the name as Madan Mohan. And similarly, account type I have changed, branch address I have changed. If needed, you can also change the email and mobile number as well. But please make sure you are passing the same account number that you received. So this is the account number that I received from the fetch operation. So the same account number I need to pass to the update operation as well. The reason is, whenever the end user is trying to update his account details, I want to allow him to update his own mobile number, email as well. Since account number will not change and user will not have any control on that, I build the logic behind the scenes in such a way that based upon this account number, the customer and account details will be fetched. On top of that, the updated data will be applied. So that's why please make sure the account number you are passing whatever account number that you received as part of this fetch operation. So now I'm just clicking on the send button and you can see I got an status code 200 and request processed successfully. Before we try to test this delete operation, let me show you the data inside the H2 console. So this is my H2 console. Let me first see the customer details. So these are the customer details. The name also is updated. And similarly, inside the accounts table, you can see the account type is changed to current and the branch address also is updated. And my auditing columns are also working perfectly. So this is working perfectly. Now let me show you the delete operation. So for the delete operation, this is the API that we need to invoke. And to this delete operation, we need to pass the same mobile number that we have inside the database. So I'm just taking this and I'm pasting the same value. As soon as I click on the send button, you can see I'm getting a successful response. Now if I go and check in the H2 database, and here I'm trying to run the query again, you can see I don't have any data. So this means all my 4 REST APIs are working fine by having the H2 database as the supporting database. So this is the simple Maven application that we have. You can also find this Maven application inside this GitHub repo. I'm going to mention this GitHub repo URL inside the description of this video. And inside this repo, you can see I have a folder begin where I have uploaded the initial accounts Maven project. And during our discussion, we are going to implement many other changes. And the end product or the end Maven project I have uploaded inside this end folder. So this is just for your reference in case if you want to explore more about this application. So now everything is clear to you about the application. As a next step, let's try to change this Maven application to point to a MySQL database. Usually whenever you want your Spring Boot application to point to a MySQL database, what traditional developers they will do is they will install the MySQL database and server inside their local system, which is a very cumbersome process and it will take a lot of memory and space inside your laptop. But the developers who are familiar with the Docker and Docker installed inside their system, they will simply spin up a MySQL container and they can point their Spring Boot application to the Docker container. So let me show you that. So this is my terminal. I'm just making sure the Docker is installed inside my system. If you don't have Docker installed inside your system, please make sure you are installing Docker. And at the same time, we should also make sure we have the Docker Compose also installed inside your system. So the Docker Compose version I'm trying to execute. So the both commands, they are giving a output to me, which means both Docker and Docker Compose is installed inside my system. So please make sure you also have these Docker installed inside your system and it is up and running. Whenever you install Docker, it will also install the Docker compose behind the scenes. So when you install the Docker, you will get an icon like this where you can see this is a Docker dashboard. And inside this, I can see what images I have, what containers I have running. So first, since I want to set up a supporting MySQL database for my Spring Boot application, first I need to have an Docker image of MySQL database. For the same, I'm going to run a command which is docker pull MySQL. So this will pull the Docker image into my local system from the remote repository. So Docker image is just like a Java class. Once you have Java class, you can create any number of objects. Very similarly, once you have a Docker image, from the same Docker image, you can create any number of containers. A container inside Docker represents the running instance of a Docker image. So using the same Docker image of MySQL, I can run multiple MySQL database with the help of Docker containers. So let this MySQL Docker image download into my system. Post that, I will show you how to convert this Docker image into the Docker container. So the image is pulled into my system. We can also confirm by looking inside the Docker desktop. So here you can see there is a new MySQL image downloaded. So now in order to have a running database inside my system, I need to convert this Docker image into a Docker container. As of now, you can see there are no running containers inside my system. So let me try to run a command. So the command that I want to run here is docker run --p. P indicates port. On what port number I want to start my MySQL database. The very first port number, which is 3306, indicates using this port number, I want to expose my MySQL database to the applications which are deployed outside my Docker network. So whenever we are trying to create a container from a Docker image, it will have its own isolated Docker environment until unless we expose the service with this very first port number that I have mentioned. The service will not be exposed to the outside world of the Docker network. So that's why we need to make sure we are mentioning 3306 here. And the second port number is a port number which my MySQL database is going to start inside the Docker network. Of course, the default port number considered by the Docker image is 3306. I'm using the same here, and post that I'm giving -- name and what is the name of my container. The name of the container that I want to have here is accounts.db. And after that, I'm going to give some environment variables to my Docker container. Since we are creating a MySQL database, we need to provide what is the root password. By default, the root username is root itself. So the password also, I'm trying to give the same value. So -e indicates environment variable. And the environmental variable that I want to pass to my Docker container is MySQL_root_password. And the value is root. And the second environment variable that I want to pass here is MySQL database. Whenever we set up a MySQL database, we'll just get a database server with some predefined databases or schemas created inside it. But since we want to have our own schema or database inside the database server of MySQL, I'm trying to pass this second environment variable, which is MySQL_database. And to this, I'm passing the value as accounts database, which means when my MySQL database setup is completed, I'll have an schema or database with the name accounts database inside my MySQL server. And at last, you can see there is a -d, which means detached mode. I don't want the logs to be displayed inside my terminal. That's why I'm trying to run in a detached mode. And after all these details, we should give what is the image name towards the end. So the image name of MySQL database is MySQL. The same we have pulled from the remote repository as well. So let me execute this command, and you can see it gave an container ID as an output. We can also confirm if my MySQL database is running behind the scenes or not by going to the Docker desktop. Right now you can see under my containers, there is an database running with the name accounts database, and it is exposed at the port 3306. I can also try to connect to this database. So let me open an MySQL client application, which is SQL Electron. SQL Electron is a very lightweight client application of MySQL. You can download this. It's an open source application. So here you can see I'm going to create a new connection. I already have a connection with the name local MySQL. Let me show you the connection details. So this is any name that you can give here, and the database type is MySQL, and the server address is localhost, and it is running at the port 3306, and the username is root, and the password also root. So with these details, if I try to test the connection, you can see I'm able to successfully connect to my MySQL database, which is running as part of a Docker container. So let me save these details and connect to this database. And you can see there is a database also created. And inside this database, there are no tables as of now. So now we have an Docker container MySQL database up and running. As a next step, I'm going to configure these details into my Spring Boot Maven application. Of course, we are not yet discussed about the new feature introduced inside the Spring Boot 3.1.0. We are going there, but before that, I want to show you all the pain points or the problems that developer has to go through. So here first, let me stop this application. The very first change that I want to do is inside the pom.xml, first I need to remove the dependency related to the H2 database because we no more need the H2 database inside our application. So let me remove this. Instead of H2 database, I'm going to add the MySQL related dependency. So this is the MySQL related dependency that I have added. So let me save these changes and load the Maven changes. After this, we can go to the application.yaml, and here we don't need this driver class name. We don't need these H2 related configurations and database platform which is related to H2. We can delete this. So now we need to pass what is the URL of my MySQL database, what is the username and password. Username, you know, it is root, and the password also it is root. Coming to the URL is going to be JDBC MySQL localhost 3306, and what is the database that we have created. The database that we have created is accounts.db, the same one we have to give here. Now, as a next step, during the startup of my application, I want these tables to be created inside the MySQL database. So by default, Spring Boot application is going to run the scripts present inside the schema.sql only for the H2 database. But if you want the same behavior for an production ready databases like MySQL database, you just need to define a new property with the name spring.sql.init.mode with the value always. With this, we should be good, and we don't need this hibernate DDL auto update since we have introduced a new property which is mode always. So let me save these changes. Now I can do a build. Once the build is completed, I can start my application, and this time my application will point to the Docker container MySQL database that is running behind the scenes. And it is also going to create new tables, the name, customer, and accounts. So let me start this new application in debug mode. So now my application started successfully. So let me go to the SQLectron. Here, let me disconnect and connect again so that you can see the new tables that got created. So accounts table created, but there is no data. And similarly, customer table also created, and it also does not have any data. So now I'll quickly test my REST APIs. First, I'll try to create a new account. Post that, I'll take the mobile number and mention the same here and try to fetch the details. Next, I will take this account number and mention the same inside my request body of update operation. And I'm trying to invoke this API also. Seems I have mentioned the account number inside the mobile number, which is not valid. So let me revert this and mention under the account number. So let me invoke this update operation. The update operation also is completed. So now if I go to the database, so first let me check the customer table. There is a customer created and it is also updated. That's why you can see the values of updated at and updated by are populated. And similarly, under account also, we have a new account created, and the same also is updated with the new account type and branch address. So this is working fine. Let me also test the delete operation as well. I'm trying to invoke this delete operation, and the delete operation also completed successfully. Now, if I try to check the records inside my accounts database and customer database, you can see they are empty. This confirms that my integration between my Spring Boot application and the MySQL database which I have deployed as part of Docker container is working fine. So throughout this video, you might have seen the steps that the developer has to follow whenever his own Spring Boot application need and supporting component like database or message queue or any other component. So he has to make sure that he's pulling the Docker image and he's trying to run that image as a container. And every time he's trying to start his application, he has to make sure that the container also running and the connection details he has to mention inside the application.yaml. So this is a very painful process. So this is where the new module of Spring Boot come into picture. So let's try to explore the documentation of this new module so that based upon the documentation, we can try to implement the same inside our Maven application. I came to the website spring.io. Here first I'll click on this Spring Boot project. As of now you can see 3.1.0 is the latest version that got released recently. Here let me go back to the overview and click on this release notes section. This will open a new website, and inside this GitHub web page I can look for the release notes of 3.1. So let me click on this 3.1. And this is the entire release notes of the Spring Boot 3.1. And using these release notes, we can try to understand what are all the new features that got introduced as part of this new version. So let me look for Docker Compose. So you can see we have a section explaining about this new module, which is Spring Boot Docker Compose. So this new module provides integration with Docker Compose. Whenever your Spring Boot app is trying to start, this module will look for the files with the following names. And inside these files, you can define all the Docker service dependencies that your application has. So based upon what you define inside these compose.yaml files, the Spring Boot application is going to make the out-of-box configurations, and it will automatically start the containers of the services that you have defined inside the compose.yaml. Once a container is started, it is going to use those connection details automatically to connect to the MySQL database or message queues. If you need more documentation about this new module, you can also click on this reference documentation, and this will open to the official Spring Boot documentation about the Docker Compose support. So this is a very detailed documentation. So they have provided what is the Maven dependency that we need to add. And similarly, if you are using Gradle, you can use this Gradle dependency details. So whenever you add these dependencies to your Spring Boot Maven application, it is going to scan for the file with the name compose.yaml and other common compose file names like we discussed previously in your application directory. Based upon what you define inside this compose.yaml, behind the scenes, my Spring Boot framework is going to initiate the Docker Compose up command. And once all the containers are created, my Spring Boot also automatically establishes the service connection beans for all the supported containers. On top of that, whenever you are stopping your Spring Boot Maven application behind the scenes, first this command, which is Docker Compose stop, will be executed. Post that only my application is going to be shut down. So this is a very high level introduction. If you can scroll down, you will have more other details. So if you see, so these are all the services that is supported by this module as of now. If the Spring Boot application is going to see any Docker container with the names Cassandra, it is going to create the Cassandra connection details. Similarly, if it is going to see anything related to MariaDB, MS SQL, MySQL, Postgres, or Oracle, it is going to create a bean with the JDBC connection details behind the scene. The same applies for MongoDB. Similarly for RabbitMQ, Redis, Zipkin. So these are all the Docker containers or services that are supported by this module, and behind the scenes it is going to create the connection details also automatically. So let's try to see this module in action inside our application. Before I try to make any changes inside my application, first I'll stop the existing accounts database that is running inside my Docker desktop. So let me stop this container, and I'll also delete this container. Once the container is deleted, I can go to the images and I can also delete the MySQL Docker image so that I can show all the automated way of downloading this image and running the container with the help of Docker Compose module. I hope you're clear with the plan. So let's go to the workspace. Here first let me stop the server, and post that I'm going to delete all the connection details. So the connection details here, you can see the data source like URL, username and password. I'm going to delete it. Post that I'm going to save this application.yaml. Once we delete these details, I'm going to add the new dependency inside my pom.xml. And this dependency is Spring Boot Docker Compose. So this is the dependency that I have added. So let me load the Maven changes. As soon as I add these dependency inside my application, the integration between Docker Compose and my Spring Boot is going to be enabled. First, let me try to start the application and let's see what is going to happen. So I'm starting my web application. I should get an error. Let's see what is going to happen. You can see here, I got an error saying that no Docker Compose file found inside the directory where my workspace is present. So this is the workspace. So inside this working directory, which means inside my project, it is looking for the file compose.yaml. So let me go to the project. So inside this accounts project, I'm going to create a new file with the name compose.yml. Inside this compose.yaml itself, we need to define all the Docker services dependencies that our Spring Boot application has. As of now, we have dependency on only one service, which is MySQL database. So let's try to define those details here. Before I try to define some services inside this compose.yaml file, let me give a quick difference between a normal Docker and Docker Compose. Using normal Docker commands, we can only start a single container at a time. If you want to start multiple services like one MySQL database, one MongoDB, one JMS queue, one Redis database. So if you have multiple services, then you need to issue multiple commands manually whenever you are using Docker commands. To overcome this challenge, we have Docker Compose. Using Docker Compose, we can define all our service requirements or container requirements inside a single YAML file. Once we define all the services inside the Docker Compose YAML file, we can issue a single command which is docker compose start, which will start all the services or containers that you have defined inside your YAML file. And very similarly, you can stop all the containers with a single command which is docker compose stop. That's a difference between normal Docker and Docker Compose. So now coming to our Spring Boot Maven application, our Maven application has a dependency and a single Docker container of MySQL database. So as of now, I'm going to define one service inside my compose.yaml file. But if you have a scenario where you have dependency on multiple Docker containers or multiple Docker services, you can define all of them inside this YAML file. So there is a format that we need to follow whenever we are trying to define all these services inside YAML file. I hope you're familiar with the format. Otherwise, you can simply follow the discussion here. The very first tag that we need to mention here is services. So under these services, we can define any number of services. So I'm just giving enter and there should be a tab space. And the service that I want to define here is my MySQL database, which will be a supporting component for my accounts application. So that's why I'm going to choose the name as accounts.db. So this is the service name that I want to give, and this name can be any value. Using this service name only, we can identify our services if we have multiple services defined inside your compose.yaml file. Once we define the service name, the next value that we need to give is what is the Docker image that we need to consider. The Docker image name that we need to consider here is MySQL. And post that what is a container name. But please make a note that container name is an optional configuration. You can simply ignore as well. So the container name that I want to give here is accounts-db. Post that we need to make the ports configuration that we want to expose the port 3306 to the outside Docker network. So the same I have mentioned here. At last, we can mention the environment properties. The very first environment property that I want to define here is what is a MySQL root password. So that's what I'm trying to mention here. The root password that I want to consider here is root itself. And the next environment variable that we need to give here is MySQL database. What is the database name that we want to create behind the scenes whenever my MySQL database server is set up? So the database name that I want to give here is accounts DB. So the same value I have mentioned here. So with this, you can see I have defined a single service which is of type MySQL. Very similarly, I can define any number of services. I can define one more service with that of type MongoDB, Cassandra, Redis, RabbitMQ, Kafka. So it's up to me on how many services I want to define inside this compose.yaml file. But since right now our application has only dependency on MySQL, we should be good. So let me save these changes. So now are you ready for the magic? So let me go to the accounts application, and here I'm going to start my application in debug mode, and I'll also show you the console, what is happening behind the scenes. So if you see inside the console, my Docker Compose module, it detected a compose.yaml, and that's why it is trying to download the relevant images. And once the Docker images are downloaded, it is going to convert them as a containers. Once the containers are created, the connection details also will be leveraged, and automatically configurations will be done out of the box behind the scenes. So you can see the kind of work that is happening behind the scenes. Since I don't have this image, and since I'm creating this container very first time, it is taking time. Otherwise, it is going to be super quick. There is an error inside the console. Let me check if I have done any mistake inside my compose.yaml. Here, the spelling is wrong for the password. So it should be PASSWORD. So with this, we should be good. Now let me try to start the application again in debug mode. Let's see this time if it is going to start successfully. So this time you can see it is not pulling the image again because it's already pulled the image previously. And you can see my application started successfully. I can go to my Docker desktop. Here under the containers, you can see there is a container of MySQL created and it is running. And similarly, there is an image of MySQL which is pulled by my Spring Boot Docker Compose module. So now let me go to the SQLectron. Here, the connection details are going to be same, like localhost 3306 and the password, everything is same. So let me save and try to connect. If you see, as of now, there is no records inside the accounts and customer. Let me try to invoke REST APIs. The first API that I want to invoke here is related to create. So let me invoke this request. So the request process successfully. Let me go to fetch and try to fetch the details. So the details are fetched. So let me take this account number and go to the update operation. Here I'm going to mention the same update operation and invoke the update operation. So the updation is completed. Now let me go to the database. So I'm trying to check the customer table. There are some records. Similarly for accounts, there are some records. So this confirms the integration is working. And you can see the beauty of this new module that got introduced. As a developer, I just have to define my service dependencies inside my compose.yaml. Once I define these details, I'm good. The heavy work will be taken care by the Docker Compose module inside the Spring Boot framework. Behind the scenes, it is going to pull the Docker image. It is going to create the Docker container. It is going to configure the connection details. If you can check inside my application.yaml, nowhere I have mentioned the connection details of my database, but all the auto configuration is being done by this new module introduced by the Spring Boot team. If you check the official documentation, so these are all the standard Docker images and containers supported by the module officially. Based upon the official Docker images, like for MySQL, the Docker image name will always be MySQL. Similarly, Cassandra, Elasticsearch, Postgres, MongoDB. So these are all the images that is officially supported by the module. But sometimes you may want to use your own custom image that you have built. In such scenarios, you can make the configurations like you can see there is an example given here, like for Redis, they're using their own company Redis related custom image. But to make this Docker Compose work automatically with the help of Spring Boot, they need to define these labels information saying that these image details they want to tag to the label Redis. You can see here, this is the value that they should be mentioning under these labels. So based upon these label details, the remaining auto configuration will be taken care by the Spring Boot framework. And sometimes you might have defined multiple containers or services inside your Compose file. Maybe for some testing or few days, you want to skip a specific container or service, you can simply define this label configuration. With that, this Redis service will be skipped by the Spring Boot framework whenever the compose.yaml file is being processed. Similarly, if you can scroll down, there is no mandate that you should always have the specific name of compose.yaml file in a specific location. You can define your own YAML file with your own custom name inside any location. In such scenarios, using this property, you need to mention what is a YAML file that you have created and what is the location where it is present. Very similarly, we can also define container readiness details and controlling the Docker Compose lifecycle, whether you want only start the services but not stopping them. So all this behavior you can control. My request is to read all this official documentation if you want to use this Docker Compose module in a full-fledged manner on day-to-day basis inside your local environment. I hope this is all clear to you, like what we have discussed. Like I promised, the final source code of the Maven application that we have discussed, I have uploaded inside this folder location. Please check the same if you have any questions. I have also mentioned the important links, the commands that I have used. So please refer to this information if you have any questions. If you like this discussion, please subscribe and like the video. And if you are looking for an in-detail course related to Spring, microservices, or any Java related framework, please refer my website, which is easybytes.com. Inside this website, you should be able to see all the detailed courses that are built by me. So please feel free to refer the same and enroll if interested. Thank you. And I'm assuming you're super excited about this new module. And I hope you're going to use this to a full extent on your day-to-day basis. Thank you. Bye.